Hello everyone, I'm Varun. So in the part 2 of this session, we are going to discuss how files actually stored in the hard disk. Okay, so basically we are going to cover the topic about file system. So let's begin. So this is a part 2 of the series. So first of all, what is storage? Okay, so storage devices are the devices which actually contains the data where we used to put our all the data, but the data which they contain is only in the form of binary format, is in the form of bits. Okay, the storage medium was like in older times, what storage medium used to have, it was a tape, drum, disk, or IC integrated circuit. Okay, these are our storage devices we used to have. Now, when we are talking about the storage device, so but these are actually the hardware. But when we are when we are thinking of a storage like in abstract way, we think the storage like this, a array of memory. Okay, so we keep on putting the data, and this array of memory is actually getting filled up as we keep on in like putting the data on our on our basically on our hard disk. So this array of memory is actually got filled up. So this is what like we assume the memory, like we see the memory, okay, in our imagination. So like in there are some points related to storage. Okay, so the older computers we have, okay, in older times the computer which we have, they used to perform like they have some limitation. The limitation is that they used to perform only one computation. Okay, so like there are big calculator, big system which are only doing the calculator or calculating operation. Okay, so corresponding to that system, you can consider this is a big system which is doing the calculating operation, and this system is attached to a one big file. Okay, there is only one big file which is attached to, because this system is actually performing only one type of operation. So it will keep on generate the output, and it will keep on producing the output, and that output is got written in this file. Okay, at that point of time, like there is no issue of using the big, since our operation is only limited to one. So that's why this one big file is actually fulfilling our, basically is fulfilling our needs. We just want to save the output. But in the current time, okay, as the computational power and storage capacity improve, then it becomes necessary to store more than one file at a time. Okay, since you know that in today's time we have a high power systems. Okay, the system which we are going to use, they have we can work at like multiple files at a time. Okay, we are also generating multiple data. Okay, so we also need multiple, like it is not that we will put our whole system data only in one file. If you open your like system folder, you can see that there are thousands of files present there. So basically now in the current time we are actually dealing with like multiple files environment. So how it becomes actually possible to like going from one big file to multiple one. So the simplest one is the how to store the file. The simplest option is to store file in a linear order. What does it mean? What you have to do, like in your hard disk, okay, whatever the storage medium you have, we first put our file, first file, then you will put our file, second file, then you will put our file, third file, then you will put our fourth file. In the order you will keep on putting your data. Okay, right now, like in the previous one, the example which I've given you, like in the older time I've shown you the one big file. Okay, this is the one complete storage which we consider as one big file, and we are keep on like filling it. But later, when I'm talking about like how to store multiple files, we are considering this whole chunk of memory. And first we have put the first file, then we put our file B, and it has taken this much amount of storage. Then we have put file C, then we have put file D. But how does computer know where files to begin and end? Suppose I want to open the file D. Okay, but how does computer like going to know, okay, file D is actually starting at this point and file C is actually starting at this point? So we have to maintain something now. We have to maintain some extra information. So since you know that storage device only store bits, okay, so we need a special file like like which will work as a which will be an extra file, okay, which contains the information of all the files, okay, like from like at which position file 1 is present, at which position file 2 is present, and that special file name is directory file. If I give you an example, suppose you have a book, okay, so there in the book you have many chapters, and like to access the each chapter very fastly, we have a index, like we have an index page in the beginning. So referring the index page, it becomes very easy to access each of the chapter. Then you will directly have the information, okay, like which chapter is present at which location. So that is the benefit of directory file. It will tell you, okay, which file is present at which position, and if a computer wants to open a file, then then where it will find that file. So suppose now file A, file B, now we will put a directory file in the beginning. It is similar like index, that index page, which we used to put in the front of the book, like in the beginning of the book. Similarly, in our in our hard disk zeroth address, we will put our directory file. Okay. And after that, we will keep on inserting like different files. Directory and directory file. Okay. Now, first directory file will be present at the location 0. Okay. And inside directory file, you will find all the file information, all the information of all the files that are present in the storage. So it is actually like this. Since you know that in this storage file A, there are 4 files. Okay. Now our basically directory file will keep that information, file A, file B, file C, file D, but it will not actually put the file A, file B. It actually put the name of the file: to-do.txt, carry.pm, theme.wave, script.doc. Okay. So now with respect to that file name, it also stores some other metadata also. So the metadata, the extra information is created date, last modified date, owner, who is the owner of that file, access rights. Okay. Now you will see that it is not just it is storing the name, it is also storing the create, modified, owner, read and write. Okay. But with that, we also need one more information. We also need to store like at which point this file is actually present, like at which location this file is present and how long space they are taking. So we have written begin 10 and it is of length 8. Okay, it is saying, okay, this to-do.txt is actually present at the location 10 and it is taking the eighth space from that 10. Basically, it's starting from 10 and taking 10 plus 8, that is 10 to 18. 10 to 18 position is actually occupied by to-do.txt. Carry.pmp is actually occupied 18 plus 2, 18 plus 13 space is actually occupied by carry.pmp. So directory file actually giving us the information of all the file that is present in our storage so that we can like fastly access the file. Otherwise, if we don't have any directory file, then it will be very difficult to access all those files. Okay. So if we want to add file, remove file, change file name, then we'll do all these things in the directory file. Okay. Suppose later you want to add some file, then after adding the file in the storage, you also have to put the directory file inside here. If you want to modify a file, then you also have to update the file in the directory file also. Suppose you have like modified the file, then in that case you have to update the last modified time. Okay. And who actually modified that, like basically suppose you have added extra amount of data, then you have to increase the length of the, because now you have occupied, now you are occupying more number of space than previous one. Okay. So if you want to, if you want to add a file, remove a file and change file name, then we have to update the information in the directory file. Okay. Now you see it is similar like this. When you like suppose you have a book and you are changing some content of the book or you are extending some chapters. So when you are expanding your chapters, then you also need to change the index of the book so that if you will get the information, okay, this chapter has extended this much. Okay, so now what is file system? File system is something which manages and keep track of stored files. That is known as actually file system. File system is actually a part of an operating system that manages and keep track of all stored files that are stored in actually the storage. Okay, so the current file system which we are talking about is a flat file system, the which we have discussed right now, the directory and with all the files like this. So this is a flat file system because all files are actually stored at one level. We have a one level file, one level structure where we are storing all the files in a linear manner. But this file system, this flat file system has some problems. Okay, storing the file like in back-to-back manner is a problem actually, because if you want to add some data like to2.txt, then there is no room without overwriting the part of carry.pmp. So suppose like we have this. Now suppose to2.txt has this, but later you want to extend some data to to2.txt. You want to put some extra data on to2.txt, but to2.txt is already full. So if you still do that, if you forcefully do that, then in that case, it will override the data of carry.bmp. Okay, because it will go till this position and it will create the problem. And you will remove, like you are actually, uh, uh, like while extending the data to .txt, you are not caring about the carry.bmp data. It will go lost. Okay, so now what is the solution? So to solve this problem, modern file system does two things. Okay, first they store the file in blocks. This leave an extra space for changes called slack space. What does that mean? So what we'll do, we actually, this is our whole storage. Okay, and we will break our storage into blocks: block 0, block 1, block 2, block 3, block 4, block 5, and similar like this. Okay, so what is the size of block 0, or what is the size of block 1? It's already predefined by the operating system. Suppose it has been decided that okay, each block will be of 5 MB. Each block will be of 5 MB. Then block 0 is 5 MB, block 1 is 5 MB, block 2 is 5 MB, block 3 is 5 MB. Now block 1 is actually, now block 1, now to.txt is actually lying in block 1. Carry.pmp, it is not block 0 is any different thing. It is just a naming convention. We are just saying that block 0 is the first 5 MB, the next 5 MB is the block 1, and the next 5 MB is block 2. Okay, and we will check that okay, to.txt coming inside block 1. Okay, since we have defined already that block 1 size will be a large, like we already defined the block sizes should be 5 MB, then when we put the file, then there will be an extra space which will be left. Okay, then there will be extra space which will be left, because after putting to.txt in block 1, we will not put carry.bmp in the same block. Okay, we will put the carry.bmp in the block 2, and it will leads to like put some space here. Like you can see that there's some space left here. Also, after storing theme.wave in block 3, we will not put the script.doc like after that. We will put into the block 4. So we are actually putting each of the file in individual blocks. And by doing that, we are getting an advantage of like getting some space, getting some extra space there here also. Okay, and this space is actually known as slack space. Okay, you are not actually directly putting your files in a linear manner. You are just putting your files in a linear manner, but in the blocks fashion, putting the files in the blocks. So this space is actually slack space. So what is the advantage of this scheme using this block 1? So the advantage is actually our directory file needs to keep track of what block each one is stored in. In that case, we also going to change our directory file. Previously, it was it was like we are actually storing the position, but right now we are storing the blocks. Okay, to2.txt is actually in the first block. So this is block 1. You can see that carry.pmp is actually lying in the block 2. Okay, this is carry.pmp lying in the block 2. Theme.wave is actually lying in the block 3. Now you can see the 3 one. And script.doc is actually lying in the block 4. Now we are actually talking in terms of blocks. Now we are actually talking in terms of blocks. Now, what is the second thing which modern file system does? The second thing is allow files to broken up into chunks and stored across many blocks. Okay, suppose Suppose we add more content to 22.txt. Okay, in that case, the file become too big to saved in one block. Okay, so now suppose this is 2.txt and it is already full, but I want to put extra data on this. So since you already know that block 1 is already full, okay, I cannot put extra data on that. So in that case, and also I don't want to override the carry.bmp. I don't want to override the space of carry.bmp. In that case, what we will do, we will allot the next block, next free block. So block 2 is already assigned, block 3 is already assigned, block 4 is already assigned. Now we will put our extra 22.txt data in the block 5. Okay, since you know that block 5 is actually empty. Block 4 is not empty. Actually, block 4 is containing script.doc, and this is the space of script.doc. This is the space of theme.wave. But block 5 is actually empty. So we will put our data, extra data of 22.txt in block 5. So now you can see that 22.txt extra data is actually put in the block 5, and also we are also going to update our directory file also, since you know that 22.txt containing data in block 1 and block 5 also. So in this case, our directory will also store the list of blocks and per file. What that means, you can see that 22.txt is containing first block 1 and block 5. Okay, now we can put as many as block we want. Suppose later 22.txt also want extra space. So after filling up the block 5, we can also allot block 6, and we can write here 1,5,6. Okay, this is how we manage, this is how we are managing, like giving unlimited amount of space to any of the file. If later, like if suppose carry.bmp also want another, like some more space, okay, we added some more data in carry.bmp, then in that case we will allot another block to it, like suppose block 6, and we will put here 2,6. Okay, in the directory entry, okay, this carry.bmp is actually taking block number 2 and block number 6. Okay, in this case, you have seen that our directory is actually storing the list of blocks. It is not the single entry, it is a list of blocks. Okay, and thus we have various files of variable size that can be easily expanded and shrunk by allocating and deallocating blocks. Okay, so basically we are like if suppose later we remove the data, we remove the data of block 5. Okay, in that case, we will remove that entry also. We will remove that entry from the block 5 because we are deallocating. When we are allocating, we are putting the blocks here. When we are deallocating, we are removing it. Okay, so now let's move to the deletion of file. Suppose we want to delete the file carry.bmp. Okay, to do that, we just have to remove the entry of directory file. This one block become free. Okay, since you have that previously, we have carry.bmp. Okay, now we are going to delete file. You just have to remove the entry from here. Okay, you don't need to delete the data from the actual storage space. Okay, you don't need to, because when the extra data will come, when the new data will come, it just got override. Since in the directory file, it is already shown that, okay, this space is actually available. The block 2 is available. So when you are actually deleting the file, you just need to delete the entry from here. Okay, we are not going to delete the actual data from the, basically from the storage. So we didn't actually erase the field file data in storage. We just deleted the record of it. Okay. At some point, that block will be overwritten with new data. Until then, it just sits there. Okay. So basically, the data will always be printed here. Okay. You just only care about to delete the entry from the directory file. Okay. Later, when a new data will come, it will just overwrite it from here. Okay. So this is the reason. This is actually happen in our system. When we delete our data, actually, it is just remove the directory entry. It won't remove this basically from the storage. It later get overwritten. Okay. This is how our recovery of data actually works. So recovery for you know about recovery softwares. Okay, there are recovery software which actually retrieve the non-overwritten data. So what they did, they just go to the hard disk. Okay, and they just get all the data, okay, which is actually present there. So carry.bmp is actually deleted from here, but this software, this recovery software will get the data, because by just tracking all the storage, like it will track the storage devices, and from the storage devices, it will just fetch out all the data that is not deleted from here, that is not overwritten here. This is how actually recovery software works. Okay, because recovery software only cares about the data now, so that's why it only goes to the storage, and the storage it fetch out all the data that is present in the hard disk. But while deleting the file, we only care about deleting from the index entry. We don't care about deleting from the storage. Okay, but there is a problem with that. Suppose we add more content to to.txt, it will cause a file system to allocate another block to file. Okay, so the problem here is suppose we have to.txt, we have allocate another space. Okay, so now here you know that carry.pmp is deleted. Now we can use the block 2. Now to.txt will override the data from block 2, because we are not caring about carry.pmp because it is not actually present in our directory entry. That means that that space is free to us. So that's why to.txt is overwriting this. Okay, now to.txt is containing the block 1, block 2, and block 5. Now you can see that block 1, block 2, and block 5. So to.txt occupied these 3 blocks. Now suppose we add more content to to.txt, causes file system to allocate another block to file. Now to.txt has data 152. Now as I told you, to.txt contain 152 blocks. Okay. So now this situation where your to.txt data is actually present in different locations. Some part is actually present here, some part is present here, some part is present in block 5, some part is present in block 100, some part is present in block 500. So your one file data is actually surrounded in whole storage. Okay, it's some chunk is present in some position, some chunk is present in some position, and this situation is actually known as fragmentation. File getting broken up across storage like this is called fragmentation. Okay, and why it happens? It happens due to file being created, deleted, and modified. Suppose you have created some part, you have deleted some part. In that case, this situation actually arises where your data is actually present in many locations, not in 152. It could be 152, 100, 500, 2000, 3000, 4000, and it keep on increasing. Okay, so this situation where your one file data is actually present in multiple locations. Okay, so due to this, it will create a problem, because since your data is actually present in many locations in the hard disk, then it will be like your hard disk pointer, your storage has to access different location. Suppose you have a file, suppose you have some coding file, okay, which is a very large file, and suppose you want to open that file in your text editor. So in that case, what your hard disk will do, it will first go to this position, first position, it will fetch out data, and then it will go to the second position, then it will go to the third position. It will keep on reading all the blocks, and after reading the blocks, it will display the programming file to you. Okay, so in that case, it is actually doing a lot of back and forth. The hard disk pointer is actually doing a lot of back and forth, and it will cause a delay. It will cause a delay that you will find that your opening a file is actually taking a lot of time. Okay, in real world file system, large file might be stored across hundred of blocks, and it can cost 5 minutes to open a file. So it is actually intolerable. Suppose you have a large file and it is actually stored in 100 of blocks, 100 locations are there, and it can cost 5 minutes to open a file. Okay, then what is the solution? The solution is actually defragmentation. It copies the data so that files have located together in storage and in right order. What that mean? After fragmenting, like when this fragmentation situation arises, what we can do? We will do the defragmentation. Defragmentation basically means putting the files which have same data in the same, like in the linear order, like putting the related things together. Okay, so now you can see that previously block file data is here. Now block file data is come here. Okay, green data is here, blue data here. Okay, now you can see that your to.txt is actually containing in the linear order. Okay, block 4 is actually now other data theme.view is containing in a linear order, block 5. Now all the data is actually linear. Now, in that case, when you want to access the 22.txt, the access will be very fast because it is not, the pointer is actually not moving in different blocks at different point of time. It is just moving linearly, block 1, block 2, block 3. Okay. Previously, you can see that the data is actually, some data is present here, some data is present here. But after doing defragmentation, we are putting the related things together. You can see that 22.txt first block is there, and now when you go to the directory entry of the file, you can see that 1, 2, 3, and theme.4 and then 5. So this is all about defragmentation. So data is actually located together. Related data is actually going to locate it together. But there are some disadvantages with flat file system. Okay, so this worked only when we have less storage and only limited number of files. Only when we have less storage on limited number of files, then it will work very well. But for very large number of files, it is very impractical to store all files together at one level. Storing one level, it basically means you can see that we have a complete storage and we are keep on storing the file back to back. Okay, so this is actually, it is not good for large like in practical to store all files together, because there is no concept of folders here. Okay, since when we use our system, we have files and folder. Folder actually containing the files, and folder also contain another folder. Okay, so there is a hierarchical system which we actually use in our system. Okay, there could be multiple level. So this is our actual in our computers. This is the paradigm which we follow: the folder inside folder, folder inside folder, and other folder. And inside folder, you will find the same like many files, and folder also. Okay, so we will use actually in today's time, this file system which we use is a hierarchical file system. Related files stored together in folders, and folder can put inside other folders. Okay, in which files are stored together in the folder, and folder also can be present inside a folder. So that's why previously we are using this type of directory file structure, where we have this name, created date, last modified, and blocks number. But now we have to put another entry also. Okay, directory file also point not just to file but also to other directory. So we will add another entry which is directory, because we have each number of files. Each 22.txt, is it a directory? No. Theme dot, is it a directory? No. Script.doc, is it a directory? No. Music, is it a directory? Yes. Okay, so we have a directory file, and is a photo, is it a directory? Yes. So we will also have another entry which will tell us, okay, whether it is a directory or whether it is a file. Okay, so now the directory file is the topmost one, known as a root directory. So root directory is the topmost basically one. When you open the system, when you open the C drive. Okay, so when you open the, so C is the root directory for you. D is also a root directory for you. So there are actually root directories is the topmost one in the chain, and all other files and folder like beneath this directory along with various file paths. After that, you will find sub files, subfolders, and all those things. But all the structure is actually started from the root directory. Okay, so in hierarchical file system, you can see that in our system, we have in our root directory, this is our root directory, where we have 3 files and 2 folders, where we have 3 files and 2 subdirectories, that is music and photos. So it is something like this. So basically this is our C. Okay, this is our root, and after this I open, there are some folders, and there can also be files. I can also put some files here. So basically that our root, and inside our root we have some folder, 2 folder, and 3 files. Okay, since I told the 3 files and 2 subdirectories, music and photos. So if you want to see what's stored in music, then we directly go to that block and read the directory file located there. Okay, so if you want to go to music, okay, if you want to open the music, if you want to look, okay, what is present here, then you just directly go to the 6th block. Okay, so when you open the 6th block, then this directory of music will open. The structure will be similar. In the music, you can see that there are 5 music files are present here, and each of the file is not a directory. Why? That's why it is written created time, last modified time, and blocks, where this b.empty, where the b.empty data is actually present. Okay, these are all the blocks. So in this way, you can also open the photos directory, and it will open in the same way. Okay, so in this hierarchical file system, this helps us to easily move around files. basically using this system, either you can go to the music, either you can go to the photos, either you can go back. So you can move around from one files to another directory to another file. Okay, so it will be very easy to. So if we want to move theme away from root to music directory, we don't need any block of data. We can simply modify the two directory files, removing an entry from one and adding to another. Okay. Similarly, if you want to put this music directory to, like if you want to put this theme.wave file inside the music directory, then you just have to update the entries of directory file, remove theme.wave from here and put this into directory.music. And you just don't have to make any changes in the storage position. Okay, you just have to delete the entry from here and put the entry here in, like cut the entry from here and put that entry in the directory music. So suppose I want to basically I want to put this theme wave. So first we have to cut it from here. So you have seen that we have cut it theme.wave from here, and we have put the entry in theme.wave here. Previously it was not there. Now we have put it in the here, and all the entries are actually got copied here. Okay, we don't need to make any changes in the storage. We are just making changes in the directory file. So by making the directory change, it becomes very easy to maintain, okay, what is actually present in the basically we don't need to actually make any changes in the data to like copy the data from one position to another. We're just making the changes. So that is the reason why you have seen that if I copy some data, that's why this is the reason. Suppose you copy some data. Okay, so suppose you are copying some file from C drive to D drive, then in that case you will see that it will take some time. Suppose the file is of 2 GB, then when you copy the data from C drive to D drive, then it will take some time. It will tell you, okay, just wait 1 minute, and it will show you a bar where it will get filled up. And when that bar got filled up, in that case you can say that by like after waiting 1 minute, your data got copied in D. But in case of cut, suppose you do the cut and you paste your data in the D directory, then it will happen just frequently in few seconds. Okay, it will just show you, because in the situation of cut, the situation of move, it has only just changed the directory entry. But in the situation of copy, it has actually copied the data, copy the storage data. Okay, and it will put the actual data in other directory also. Okay. Now I'll show you some demo. Okay, so how actually it is working. So suppose I have two files, OS2. Okay, suppose I have, 1 second. Now suppose inside C drive, I have two files, this lecture 24 greedy and this OS2. Okay, so first what I'll do, I will copy this. I will do copy, and I will paste it into in the directory D. Okay, when I paste it into the directory, then you will say it is actually taking some time to copy, because it is actually making a copy of that data, okay, in the storage device. But suppose what I'll do, I will now in that case I will OS2. This is a file of some, you can say 220 MB. Now what I'll do, I will cut it, okay, and I will make a paste. So when I paste it here, okay, then it will just basically it will do that thing very frequently. Okay, because in that case it is not just make the copy of that. In that case, actually, while in the case of moving, while like doing the cut and paste, in that case it only changes the directory entry. That's why cut paste won't take much time as compared to doing the copy paste. Okay, because in cut paste it only changes the directory entry. So that's why this is how. So and theme.wave, okay, and when we have basically moved our theme.wave file from this directory root, so previously it was theme.wave is actually present in block file, But when I move theme.wave to directory music, in that case also, it is actually present in block file. Okay, so block is actually not changing. But when I suppose I copied this theme.wave here also, then in that case, theme.wave here present in block 5, and here theme.wave will present at block some other blocks. Okay, it is not actually block 5, because at that point of time, I have actually copied the data theme. But here in this case, we have just moved our data. Okay, now what is the final note? So basically, file system allow us to hide the raw bits stored on magnetic tape spinning disk. Okay, file system is actually helps you to showing you the visual of visual information of all the details of files and folders, that where your files are stored, where your folders are there, in which blocks they are present, when they are created. So it is actually giving you the information of all files and folders in a visual manner. Okay, it's very interactive manner. It helps in showing neatly and organized accessible files and folders. Actually, it helps in showing neatly and organized accessible files and folders. Okay, so this is all about file system. File system is actually helping us to giving to like helping us to interact with files and folder. Okay, so that you will get the information, okay, where your data is actually present in which files and which folder, and how these things are actually got managed by operating system. So thank you all. This is the end of the part 2 of this session.